In this video, we're going to begin the journey of solving equations. Now, I wrote part 1 because solving equations generally is pretty complicated, and there are lots of techniques you're going to learn about. And so part 1 just refers to the fact that this is a starting place for us. Okay, so let's say that we were asked to solve the following equation. X plus 2 is equal to 7. Now I know that you can see what x is. I know that you can see that x would be 5 because 5 plus 2 is equal to 7. There's another way we're going to view this that's going to be helpful when the equation gets to be a little more complicated. So here's how we're going to think. Notice that one way to look at it is that, well, we're trying to get x by itself. And on the left-hand side, that is the left-hand side of the equation, somebody added 2 to x. So if you want x by itself, you'd have to undo that operation of addition. So if somebody added 2, you could undo that by subtracting 2. So I can subtract 2 to offset the addition of 2. Now whenever you subtract something from the left-hand side of the equation, you also have to subtract it from the right. So in this case, 2 minus 2 is 0, and on the left-hand side I'm just left with x, and on the right-hand side I have 5. So that would be my answer. As you know, x is equal to 5. Now, the same logic applies if instead of trying to undo addition, if you were trying to undo multiplication. So for example, let's say that you wanted to solve the equation 5x is equal to 10. Now once again, I know that you can see what the answer is. I know that you can see x is 2. But let's go ahead and see if we can think about it in terms of undoing operations. Well, somebody's taken x and they've multiplied it by 5. Can you think of an operation that would undo multiplication? That would be division, right? So if I divide the left-hand side by 5, well, I also have to divide the right-hand side by 5. But now, like we talked about in the last video, this is 5 multiplied by x, and so 5 is a factor, and in that case the 5's will cancel, which is why we divided both sides by 5. So when they cancel, you're left with a 1, and the 1 times x is x. And on the right-hand side we have 10 divided by 5, which we know is 2. Okay, so what happens now if you combine both addition and multiplication? Which do you do first? Do you subtract to undo the addition, or do you divide first to undo the multiplication? Okay, so let's say that we had the following problem. We wanted to solve, let's say that we had 2x plus 3 is equal to, let's say, how about 13? Okay, so do you see what's happened here? There's clearly addition on the left-hand side, but there's also multiplication. And so what do we do first? Do we try to undo the addition, or do we try to undo the multiplication? And there's a way that I like to think about this. We're trying to get the x by itself. Think of the x as like a little present that a friend wrapped up for you. Okay? So if your friend wrapped up a little present, well, let's say here's the little present you're looking at. And this is a box, and the little present is inside the box. And then here's the bow. Okay? Now, if your friend gives you this present, well, what did your friend do? They put your present inside this little box, and then after that, they put a bow on it. Okay? And then they handed you this present. So, if you want to open the present, or if you want to know what they gave you, what do you have to do first? Well, you don't first open the box and then take off the bow. You first take off the bow and then you open the box. And my point is that you have to undo what they did in reverse order. So they put the present in the box and then they put the bow on it. So you have to first undo the bow and then open the box. And the same logic applies in algebra. So x is a little present that your friend wrapped up for you. Now let me ask you, did your friend first take the present, in this case the x, and did they first add 3 to that and then multiply it by 2? Or did your friend first take the present x and multiply it by 2 and then add 3? Now these are different, right? Because this is 2x plus 6, if you distribute that 2, and this is 2x plus 3. So what happened first? Did your friend first add 3 and then multiply by 2? Or did your friend first multiply by 2 and add 3? Well, clearly I can see that, I have the second situation. My friend multiplied by 2 and added 3. And that's why, just like when I open the present, I have to do what my friend did in reverse order. So the last thing my friend did was add 3, and that's why the first thing I have to do is subtract 3. So when I do that, I'm left with 2x is equal to 13 minus 3, which is 10. So that is analogous to undoing the bow. That is, I undid their last operation first. And now I'm going to undo their multiplication, and that means dividing both sides by 2. Okay? And I'm left with x is equal to 5. So whenever you solve an equation, what's important to remember is that you're really trying to undo operations, but you're trying to undo them in the reverse order in which they were performed. Okay? And we'll do more complicated versions of solving equations in the next video. Stay tuned.